Welcome, everyone. This is Ricardo Casanova, CEO and co-founder of Linke. Welcome to our webinar, where today we're going to talk about how to automate SAP deployments on AWS. We're going to wait a few minutes and wait for other people to join. So please hold on for a couple of minutes. Okay, while we wait a little bit more for other people to join, please allow me to share my screen for a second, and we'd like to get started with the prior work. Sorry. Okay. Okay, so while we get things started, let's go back to our presentation, and I think we're ready to start. So welcome everyone again. My name is Ricardo Casanova, CEO and co-founder of Linke, and today we're going to talk a little bit about how we automate SAP deployments on AWS. For those of you who joined a few minutes ago, what I've been doing here, it's trying to launch, as you see in my screen, automated deployment of an SAP system on AWS. And throughout the webinar today, we'd like to see how it's working, how it's behaving, and how we can walk through the automation itself. So let's get started. Well, first of all, a few words about ourselves. For those of us that didn't know us, Linke, we are an AWS Premier Consulting Partner. We also partner with Chef and SAP, as well as AWS as our three main partners. And we are a company that we deliver consulting services and managed services to enterprises specializing on SAP workloads on the AWS cloud. Additionally to delivering services, we also develop some products, technology products that are focused to enhance and make better SAP systems running on the AWS cloud. Today, we are the only known global system integrator to be AWS Premier Partner and hold as well the SAP competency, which is something that we're very proud of. And also that we've reached AWS Premier Partner level through our expertise on SAP workloads. So by managing, deploying, and migrating SAP workloads to AWS is how we've evolved as AWS partners till the Premier Partner tier level. In our company today, we have around 65 engineers, and between all of them, we hold over 100 SAP and AWS technical certifications. What we are proud at Linke is that most of our engineers both hold SAP and AWS knowledge, and we don't have separate teams dealing with each technology stack. Since 2017, we've worked in more than 50 projects related to SAP on AWS, whether they are new deployments or migrations, and this number keeps on growing every day. We're a company with headquarters in Barcelona, in Spain, and we also have a presence in Madrid, Paris, and Dubai, where we serve most of our customers in EMEA. And as we mentioned before, beyond the services, we also do some develop some products. Amongst them, we have Elastic SAP, which allows SAP systems to be integrated with AWS autoscaling, so that new SAP application servers are created and removed based on SAP user demand. We also have the AWS connector for SAP, which is the implementation of the AWS SDK in ABAP, so that any ABAP-based SAP system can interact and with AWS without the need of any additional middleware software or hardware. We also have some pre-installed SAP systems available through the AWS Marketplace. So these are pre-built AWS AMIs that include fresh installs of SAP systems that customers can rapidly deploy on their AWS accounts and spawn new instances with SAP software installed so that they can start working with that. These are ideal for dev and test purposes. And the purpose of our webinar today, we have what we call our SAP Automation Platform, which is a set of scripts and software that allows us to automatically deploy SAP infrastructures on AWS. So today we're going to talk about our SAP Automation Platform and how to automate SAP deployments in the cloud. But first of all, we'd like to introduce a little bit how we got here in the first place. For us at Linke, we've been working with SAP infrastructures for many years. And even before Linke, we had a long experience working as SAP basis consultants and dealing with SAP infrastructures of all sizes and aspects. Back in 2008, we already started working with what SAP started calling SAP Adaptive Computing, which later evolved into SAP LBM. And that was a very promising tool that allowed us to manage a little bit of infrastructure and try to do some automated deployments and system copies and operations with SAP systems in a very complex and rigid way for us. And beyond that, we evolved in order to start using AWS, especially for dev and test environments. And I would say that in 2012, with our startup partnership with AWS and our first trip to reInvent, we realized that there were already big companies such as Netflix and cloud-native companies, where we saw them managing tens of thousands of servers with just a few hundred engineers in their teams. And there we realized that infrastructure automation was key to success in the cloud, and that we had to take action and do something about it for SAP. And the action we took, it's been a journey of evolution where we started building those pre-installed AMIs that we mentioned before, which allowed customers to deploy predefined SAP AMIs, which was good for single instance SAP systems and dev and test, but that wasn't the ideal. From that point, we started implementing AWS Cloud Formation scripts and adding SAP software provisioning in unattended mode in order to manage the installation of the SAP systems or software on the different EC2 instances. That came out to be our first version of our SAP Automation Platform, which was functional, but yet we found that it was really, really hard and complex for us to maintain and to expand into a broader complexity of the SAP systems and their architecture. By that time, we decided that we had to adopt an infrastructure as code solution in order to have more flexibility and more power in order to maintain and develop our automation scripts for SAP. And that's where we chose internally Chef to be our partner and the tool selected for us to develop and implement all our automation in Chef cookbooks and recipes. That came out to be really, really successful for us. But we still found that when we had to install and deploy SAP systems into several EC2 instances, we still had to do that work manually. So Chef helped us deploy and configure automatically the different EC2 instances, but still we needed somehow to go step by step manually to each of those EC2 instances and specify what we wanted them to be. This changed last year, where we added Terraform as another stack to allow us to orchestrate all the deployment of a multi-system SAP system into that was covering more than one EC2 instances. This allows us to fully automate the deployment of complex SAP systems, and with the combination of Terraform and Chef, we're able to deploy complex infrastructures, including high availability setups or with multiple application servers. The road doesn't stop, doesn't end here. We are continuously adding more functionalities and more scenarios into our automation platform to cover as many SAP software combinations and architecture layouts. And we are also working in the automation of compliance and monitoring of the compliance of our SAP infrastructures in order to help customers meet and monitor the compliance of their infrastructures. Okay, so let's start with how we deploy SAP systems traditionally. Okay, so every time an engineer of any of us needs to deploy a new SAP system for a customer or for an internal customer, there are many things to be considered and a lot of work to be done. So we have to review some OSS notes, we have to review the installation guide, best practices for the platform, operating system, and database that we are going to deploy, we need to do some sizing in order to select how big is going to be our EC2 instances. We have to plan for EBS layouts depending on the role of each EC2 instance or the type of database we are deploying. We need to take care of security, how we are going to how we are going to set up our IAM roles, our security groups, our networking. We have to decide how to deploy our high availability, if we want just a single AZ, multiple AZs. And of course, we have to select which SAP system we're going to install, what software product, version, support package level, and so on and so on. So there are many variables that define each SAP system and each deployment we do. And approaching the deployment of SAP systems manually has the risk of a different outcome depending on the person and the mood of that person and how lucky he is doing the implementation. So, as an example today, what we will see in the different code runs and the automation that we have in our example today in the webinar, we're going to deploy a single NetWeaver 7.5 on HANA, split it into two EC2 instances. One will act as a database instance with the HANA database installed there. And then we will have another EC2 instance that will have both the ABAP Central Services instance and the primary application server. So it's an SAP architecture that is very common, something that we see very common in our in many of our customers, although we don't include any high availability. But for the demo and webinar purposes, we think that it's relevant enough to show the power and the potential of automating SAP infrastructures with AWS. Of course, when we need to deploy this type of SAP architecture, there are lots of things that we need to take into account and to set up prior to doing the effective installation. Sorry. So in the case of a deployment on AWS, we need to define the AWS region where we want to deploy the SAP system, the VPC ID, the security groups, IAM role for the EC2 instances, the EC2 instance types, EBS layouts, select the right operating system AMI, our tagging strategy, configure the OS settings, IPs, domain, packages, networking stuff, and so on and so on. And beyond infrastructure, when we get into the SAP specifics, we need to know what is the SAP SID that we want to deploy, instance numbers, SAP HANA SIDs, SAP software mount points in the different EC2 instances. If we're going to set up the sub-mounting using AWS EFS, the specific SAP software provisioning manager settings that we want to execute in order to install our specific SAP product version, where we want our SAP HANA data and log volumes to be deployed, and so on and so on and so on. So, as an example, we have the AWS Quick Start. Specifically, there is one existing about NetWeaver 7.5 on AWS. Where if you access that, if you check that document, you will see that there are many aspects and variables that you can customize in order to deploy your SAP infrastructures on AWS. Okay, so how would the typical deployment workflow work? So now we know we want to deploy the architecture we mentioned before, but instead of doing it through automation, let's face the work manually. So in a typical world, as a rough series of tasks, any engineer will start provisioning our central services and primary application service instance, then would configure the operating system for that instance, download the SAP software, install the software, then clean up all the installation software and so on. Then would go into the database instance and do the same over again and install SAP HANA software and configure all the operating system on that instance, clean up the installation, and then finally go back into the primary application instance to install the primary application server and end up cleaning up all the installation. Roughly, and depending on many factors, we always measure that this takes between 16 and 24 hours of work. So usually between 2 and 3 days is what it takes to an engineer to get all this done when starting from scratch. Of course, we assume that we are doing this on AWS, and provisioning an AWS instance, EC2 instance, is really, really fast. But we are considering just the work it takes to do all the SAP deployment. Okay, if we were considering an on-premise scenario, we will have also to add all the time required to provision the hardware. So now let's talk about the automation. What we have set up here. So our SAP Automation Platform Architecture is made of, consists of a chef server where we have our chef cookbooks and recipes, where we have all the options and roles and chef configuration that allows us to automate each of the EC2 instances that we're going to deploy. We have an S3 bucket where we already have all the SAP software downloaded, so that each of the EC2 instances is able to download from our S3 bucket the SAP software for its installation. And we have a workstation where we run and where we deploy our Terraform scripts, and that workstation is orchestrating all the activities of the automated deployment. So our workstation from one side is connected and configuring our chef server, as well as it is reaching out to the destination AWS infrastructure, being a customer, or in this case our demo scenario, and interact there with AWS infrastructure to get the infrastructure deployed. Okay. So how does our deployment, our automated deployment work? Okay. First, as we mentioned, in our workstation, we have our Terraform script that orchestrates and has this decision tree that you can see in the screen, describing the different steps that are required to accomplish the deployment of this SAP system in 2 EC2 instances, one for database, another one for central services and primary application servers. Terraform controls this decision tree, and in each of the nodes, the configuration and installation of SAP software is done with chef cookbooks and recipes. And as you can see in your screen, in the decision tree, on the lower level, you see that we will read it from down to up. We have the 2 instances that are created in parallel. And once AWS has created those instances, Terraform is assigning to the central services instance the role of a central services instance, and therefore Chef is then installing the software of the SAP software and configuring the central services instance. Once this is done, then the database instance is flagged as a database instance so that the database is installed. So at that point, while the database is being installed and loaded, the other node, the other application node, is waiting for the database to be completed in order to trigger the installation of the primary application server. If we try to install the primary application server before the database is installed and the central services instance is installed, the installation would fail. And Terraform is controlling this decision tree in order to ensure that all the different automation tasks are done in the right sequence. Okay. The execution of this automation has an execution time of 1.2 hours, so an hour and 20 minutes roughly, and therefore it's really much faster than doing the operation manually. So from this experience and many other experience that we see from the different customers where we have implemented the SAP automation, we've seen that thanks to the automation, we deploy more than 10 times faster than doing it manually. Being fast and spending less time doing the deployment makes those deployments more cost effective for the customers. And what is really groundbreaking for us and a change in the way we manage SAP deployments is that we can now treat SAP deployments and SAP architectures as a software code that that we can version, we can test, we can replicate, we can maintain through a software development life cycle, and that it is predictable. We know that always our architectures and our automations will produce the same infrastructures every time we run that. That is something that when the deployments are done by human beings, it's really, really, really rare that the two deployments are identical if they are done by two different persons. And one of the great things that infrastructure as code tools gives us as well is that we have the possibility to audit and make our SAP infrastructures compliant with existing regulation and any business requirement that our customers might have. So all these benefits for us are so significant and so important that we think that there is no way back into deploying SAP infrastructures manually anymore. And I hope you find that as well. Okay. Of course, at linke we started doing some work with compliance as well. And although we're not able to show that live in our demo today, we want to show you a small screenshot that you will see here that we also developed some inspect code in order to verify and check the compliance of our SAP infrastructures. Here we have been developing our inspect recipes to include all those SAP relevant checks and controls that we want to ensure that our SAP infrastructures are meeting with the best practices of SAP architecture deployments. Okay, this inspects recipes. Customers are able to deploy them on their Chef servers if they want, as Chef includes the compliance functionality, and work as well with AWS SSM. As you see in this screenshot, you have an example of a few inspect checks running on AWS Systems Manager. Let's have a look first and see how this is going. Okay, we see that the automation we started a few minutes ago, and we will get into more details. It's still working, and we have some HANA software being installed on the database instance. So let's go back to the presentation. We'll go back shortly into the automation. Okay, so how now let's get a little bit commercial. So how are we offering this SAP automation at linke to our customers? So first of all, we offer this as part of our managed services offering, where at linke we own the Chef server and we run the automation for you, and we provide to our customers a support, and we take care of everything for them. And also we have another offer based on consulting services, where customers might own their Chef server and the Chef infrastructure, and they want to run and take control of the automation they have. And here what we do is we deliver some consulting services. We help customers on the implementation, the training, doing custom development of cookbooks and recipes for them. And we also, of course, offer some support to those customers in case they ever need any help. Okay, we have here some few URLs where you can have some relevant information about the different tools and quick start and technologies that we're using. If you're not familiar, we always recommend you to have a look into them, which we think is always useful. Okay, so let's have a look. So let's go back to a screen and let's see how our automation is working. Okay, we see that it's still working. Roughly, we've been running this for the past 30 minutes, so there's still a long way to go, but we see that the automation is already installing some SAP software and downloading the software on the database instance. Okay, so before we go, let me show you a screenshot of our AWS console. Here you can see, let me put some order. We have these two EC2 instances. First one being the central, well, the application server central instance, hosting the ABAP central services instance and the primary application server. And we have another instance, which is a database instance that is hosting SAP HANA database. We have our Terraform workstation running on the same VPC and same subnet. This workstation is where we are running here the automation, and you can see the workstation doing its work. And we have a Windows Bastion PC, which we will use in order to connect using SAP or HANA Studio into our newly deployed infrastructure. Okay. And you can see that we have as well here a previously deployed SAP instance, which represents a previous run of the same automation we are running right now. And in case we run out of time, we'll be able to show you the details on this already deployed infrastructure. So let's have a look now at our chef server. Let me refresh the screen. Here we see the nodes, and we only see the nodes that were created before. So if we refresh the screen, we should see now, as you see here, the new nodes that have been created and that have been bootstrapped into our chef server. Here, in the chef server, we see for our different nodes, they have a run list, which is the sequence of cookbooks and recipes and configuration we want for each of the nodes, and this is how Chef delivers to the different nodes all their configuration and all the execution path of operations they need to do. As well, here on our Chef server, under the policies, we can see, first of all, the different roles we have defined within Chef in order to define the role of each of the nodes. So in this case, we have different roles for each of the SAP application software stacks. So we have a role for the database. We have a role for the ABAP Central Services instance. We have a role for the primary application server or central instance, and we have a role for the database, as well as for the primary application server. These roles have their run list and cookbooks associated that define the configuration of each of the nodes. And here in the Chef server, we have all the selection of cookbooks and recipes that we have available under the linke demo organization, which is the control environment where we are working at the moment. We have some community cookbooks such as AWS, Build Essentials, cron, and so on. And as you can see here, we have the LNK_basic. Well, all the cookbooks that start with LNK are our own linke built cookbooks, where we include all the automation that we are created as part of our SAP Automation Platform. How we have ordered and managed to organize our cookbooks, we have some basic OS level cookbooks that configure operating system level aspects of each of the nodes. Then we have cookbooks for each of the supported database that we are supporting today. So we will have a cookbook for SAP HANA, another cookbook for Oracle, another cookbook for Sybase database, and then we have a cookbook for SAP as an application. Okay. On each of the cookbooks, so if we have a look at the HANA cookbook, we have a set of recipes that help us automate and operate the different aspects related to a HANA instance. In this example, for example, we have in our HANA install recipe all the specification to install and configure and the different parameters and variables we need to feed to the HANA installer about the installation. Something that we took our time to develop within Chef is that we created some custom resources in Chef in order. That's what you are seeing here as a HANA instance. So we created a custom resource that within Chef we can call a HANA instance, and be able to operate and automate this custom resource with all its settings in a much easier way throughout the code. So there's been a very intensive work of development, evolution, fine tuning, and testing of our cookbooks and recipes. In the case of our SAP cookbook, we have many recipes as well. So, for example, we have our AWS data provider recipe, so that we specify for each EC2 instance how to install the AWS data provider agent, which is required for support and monitoring purposes of all SAP systems running on AWS. So this is just an example. We have our some scripts for automating and configuring high availability. We have also some automation for setting up SAP kernel parameters and so on. Okay, the same applies for Sybase, where we have our recipes to install and configure Sybase database, and of course the same for our Oracle database. So going back to our automation script, please let me set up a new connection to our workstation. And here I'd like to show you the different configuration files we have for our current deployment. So this directory, these files you see here are the ones that they are of the automation that is currently running and working here in parallel. We have three main files. We have our main Terraform file, our providers file, and our variables file. Okay, I'll start from the easy to the most complex. So if we have a look at our providers file, you'll see that we have an AWS provider, and then we have a Chef provider, because we are deploying SAP systems on AWS with Chef. Okay. First of all, we have for AWS the region and the credentials file in order to be able to operate into with AWS. And in the case of Chef, we have the configuration of our Chef server and different authentication mechanisms. If we have a look at our main.terraform file, here we have specified the decision tree we showed in the presentation before, which I will rescue right now for you. Please let me share that with you, and let's have a look back to it. So, okay, here we are. This decision tree you see, the implementation of this decision tree is what the main.terraform file is implementing. So if we go back here and walk over the file, first we are defining some modules and roles for the different nodes and the different software application stacks that we're going to build with Chef. So we have a role for application server, role for SAP HANA with the different variables that we are going to set up. We have another role for the primary application server. The same applies for the central services instance. We have another one for the database instance with all the parameters. And then we start with the orchestration of the automation. So first, we have the operation to set up the ABAP Central Services instance. So we apply that role to the EC2 instance, and we run a knife node run list on that node so that it connects to Chef, downloads all the cookbooks and recipes associated to the role and its run list, and starts configuring itself as an SAP Central Services instance. Sorry for that. Okay, that's what's happening right here. So after assigning the role, we get the central instance installed. Following, we have to the step where we set the database role to the database instance. As you can see, this resource, this activity, depends on a previous activity, which is setting up the database instance. Once this is completed, we run the chef knife command to apply the run list to and the role to that EC2 instance, and then we have our install database activity, which depends on installing the central services instance and setting up the database role on the database instance. Following that, in a similar way, we have the set of the primary application server role, which depends on installing the central application services instance, and following that, the installation of the primary application server software, which depends on the installation of the database and the setting up of the primary application server role. Okay, and then we have the output of the IPs of the newly created systems. So doesn't seem to be very, very complex, and as you can see, it represents this decision tree we have here, where the different steps and the parallelism is defined through the main.terraform plan document file. Sorry. So what we have left, we have the variables .terraform file, which this is where we customize and specify the particularities of our deployment. So here we have, well, first we select the AWS region we want to work. We check the IAM role that is going to be assigned to our different EC2 instances. We specify the default AMI for our operating system, the different instance sizes we're going to use for our different EC2 instances. So we have an M5.2x large for our primary application server and an R5.4x large for our HANA database instance. Following that, we have our subnets, the IP addresses of our the private IP addresses of our subnets that we want for each of the instances, security groups. We set up some tags and names for our EC2 instances. So as you see here, we named 2_NetWeaver752 CI instance that corresponds to the same you can see here on the screen. We specify the credentials files to connect to the infrastructure on AWS, our Chef server settings, and our Chef server configuration, environments, and so on, where we want everything configured. we have then we have the different set of chef roles that we're going to use for our newly installed systems. We have our run lists that specify the different recipes that we're going to apply for each of the roles. So we have for a run list for our ABAP Central Services instance, a run list for our primary application server, and a run list for a database instance. I'd like to mention here that the way we have organized the different cookbooks and recipes and roles in our automation platform allows us to freely install each of the SAP software components on different EC2 instances, so getting a completely distributed SAP system, or putting all these different roles into the same EC2 instance and build an SAP system on a single EC2 instance using the same code. So this we think it helps us a lot to be flexible in order to be able to automate complex deployments on different on distributed infrastructure. Okay. Going back here a little bit more, we see our the role names we have for our different nodes on Chef, and then after that we start specifying the host name we want for our primary application server, the host name we want for our HANA database, domain, some settings of static IP addresses so that each server sees each other. So we are adding the IP address of the HANA host into the primary application server host file, and we are doing the same for the other server as well. Okay. Following that, we specify all the settings about our HANA installation we want. So we select which HANA database version we want to release, we want to install. In this case, the HANA 0.2. We select the service package release we want to install, which revision, which components are we going to install, in this case, client and server. We select the user ID, HANA ID, HANA instance number, the size of the volume groups, the size of the sub-mount HANA directory, the size of the HANA data volumes, the size of the log files. Here you see clearly the default password we are setting up. We are working now in order to make this more secure, to integrate our automation with AWS secret managers, but that's something that our development team is still working on. We have then the settings for our SAP systems. So we have our IDs of our operating system users, group IDs, SAP kernel version we want to install, SAP SID we want to install. In this case is RIK. We select, well, we specify the database host, the instance numbers for the central services system and the primary application server, volume group size, which product we are installing, in this case that Weaver 752, platform version, which stack, in this case is ABAP. What we are doing an installation. We are doing an installation mode in high availability because we are installing application server, application components separately. We specify as well the master password. And finally, we specify the sub-mount NFS server because even though we didn't mention that before, the sub-mount share file system is configured on Amazon EFS, and this is where it is installed on the servers. Okay, so let's have a look. let's go back into our automation to see how it works. So usually when we have here, what are we doing here? Okay, run migration mode. Okay, so we are getting to the final stages of the installation of the system. So at this moment, we have the import of the SAP software being executed on the system. So that's why it takes a few minutes to complete. Okay. Going back here, we have reviewed already all the files and the contents of our Terraform automation that is orchestrating the deployment of the SAP infrastructure. We've seen in our chef server how we have organized our roles for our different nodes, and we have our cookbooks and recipes set up, and that deploy the configuration into the different nodes. And in the meantime, while we wait now to see how the installation is progressing, I'd like to, while we wait how it goes, I'd like to show you, in this case, on the previous installed system, which you can see EC2 instance type corresponds to the EC2 instance types we have specified on our Terraform files. And if we are connecting with SAP GUI into our SAP systems, we're able to connect. And in this case, if we want to have a look, we'll see that we have installed a NetWeaver 752 SAP product, which is specifically what we have specified in our automation. We can also use SAP HANA Studio to connect to our database and have a look at how it's been deployed. So here we have a view of our previous installed system, which is running with all the settings as expected, and we can connect as well into our currently installed system and see that it's still in progress, finishing the installation of the SAP system. But database is already available for us to work with. Okay, let me have let's look that things are going on. So while we wait a little bit for the final steps of the automation to be completed, I think we are ready to go through any questions you might have. So feel free to address to us any questions you might have at the moment, and I'm going to see if there are any questions we can clarify for you. Okay, so we have our first question. Okay, first we have a question around the SAP installer that it seems to change a lot on every release of SAP, and what is the impact and effort these changes have on maintaining the cookbooks parameters and so on. In our experience, yes, SAP installer changes a lot, as well as kernel versions and software components of SAP systems. So there is a significant work in our side in order to update and have a catalog of as many proven software SAP installation tools that work with the specific SAP product versions. So we might have a specific SAP installer version that we know that works with NetWeaver 7.3, and we have another version that we know that works for NetWeaver 7.5, for example. Or we have a working version for SAP Solution Manager and another working version for SAP ERP, or another one for S4HANA. So yes, there is a maintenance work that needs to be done to be updated, and for each new version that we are adding, or new SAP product that we want to support, we need to download that version, check how it works, see the differences with the other versions, update our S3 bucket with the different software components that we want to download, and test it, and ensure that everything is fine until we release that into our production chef server. So for us, this is an ongoing effort that we are doing constantly as part of our, let's say, software development process, where we are maintaining and evolving our SAP automation scripts. I have to say as well that there is little impact in our automation cookbooks and parameters. Usually, within minor SAP products and version changes, there are not so many changes on the parameters of and the cookbooks themselves. So as we are automating the infrastructure, and SAP NetWeaver, it's a common technology stack for many SAP Business Suite products, we are able to maintain the cookbooks and the automation without excessive effort. Okay. Another question we have is if we are delivering these cookbooks with our product service. As we mentioned before, if we are doing the service as our managed service operation, we are not delivering our cookbooks, we are maintaining them for you, and we are updating them for you, so that you don't need to bother about that, and customers can just enjoy the automation of their SAP infrastructures. In case you want, you are running Chef yourself, and you want to have those cookbooks for you, we are implementing those for your specific infrastructure and configuration, and we are adapting those cookbooks and recipes to meet your specific requirements. And at the end, these are customer cookbooks that ultimately each customer or each company would maintain. Okay, I see another question saying that the recipes cookbooks licenses are Apache.0 and Copyleft, and if they are available on the supermarket. At the moment, the cookbooks are not available at the supermarket. We are still offering and running those cookbooks as part of our MSP platform, and for customers that want to do the consulting or the consulting offer and want us to deploy those for them, they are the ones that they can decide whether or not they want to publish those cookbooks into the supermarket. Regarding the expense, we have another question regarding the Inspect compliance profile to see if they are open source. At the moment, we are at a very early stage of our Inspect works. We are working on initial versions of inspect controls related to SAP configuration best practices. And we don't know yet whether they will be open source or not, but so far it's still early days for us, and we haven't considered yet what is going to be the next version. Okay, let's see, we have another question here. Okay, is the source code of the demo available somewhere? Unfortunately, no. The source code you see for the demo, it's actually the same automation we are using for our current customers, and that's the code we are running for our customers. If you want to have a look and are interested in it, please reach to us, and we would love to share that with you and show it, but it's not public at the moment. Okay, let's see, we have some more questions. Okay. So let's have a look and see how the automation is running. We are running shortly of time. Hopefully, we will make it on time before we reach the end of the webinar, but I think we are in the final steps of the configuration of the primary application server. So let me try to see if we are able to log into our newly deployed SAP system. No, still not available. Okay. Let me see if there's any additional questions. I think we are almost there. Okay. Let's see. And now it looks the application server is started. Let me try again. Yes. So here we are. First time we log into the system, it's compiling. Well, we don't have a license installed, so we get the message. And installation, it's still working in the back, so it's normal to get some initial errors on the systems. But if you see, system is already installed, activity is going on, final configuration of the SAP system is installed, and you see how in the time we've been running this webinar, which is roughly 1 hour and 10 minutes, we managed to deploy a full SAP NetWeaver infrastructure in 2 EC2 instances, and installing and configuring and customizing and personalizing that installation to meet our specific requirements in a very fast and automated way for you. So let us finally check here. Well, we have here activity going on in our server, but even though we're still in the final steps of our of the installation, we can say that the deployment is almost completed in less than 1 hour and 20 minutes. So let me see if there is any other question from the audience. not. We're going to wait a few minutes to see if the job ends, which should be very, very shortly, and wait till there is any other question from the audience that needs to be clarified. Okay. Okay. In the meantime, while we wait, let me revert back to the different URLs. And if you want to reach us, you have my email address and my Twitter ID. And for any of you that would be traveling to Las Vegas for AWS reInvent, we're going to be there. And if you want to meet and talk there, please feel free to reach us, and we'll be glad to meet you in person. Okay, let's see how we are doing. Still, we're working here with final states of the installation, creating CDS views. So hopefully this will end in time, but before we run out of time on the webinar, we'd like to thank you very much for joining us today, and we hope that you find the webinar and the content of the webinar satisfactory for yourselves. And of course, feel free to reach us, or you can also check our other webinars where we also introduce our other products, such as the AWS connector for SAP. So thank you very much for your time. Hold on, we have a final question. Let me review that. Question is, how long did the development take to build the Terraform and check code? Okay, we've been doing this for many months, but for this final run, I would say that we have around 6 to 8 weeks of development effort. We're running out of time, so thank you very much for your time. We hope you liked it, and have a nice day. Bye-bye.